Anyone's fine.
Well, I was go in order. This is the. I didn't see a number 1. I saw a number 2.
Okay.
So this okay?
Yeah.
These
I
look.
was wondering if you could 45 minutes tonight because I was
back up. I just noticed the title. The free response questions. Those are the toughest there are. This is a free response question also.
They're all a free response.
They're all free. No, this one doesn't look like it is. Let's try this one. First of all, the free response are absolutely the toughest problems on
Wait, hey, David.
Yeah.
I was wondering if I could only do 45 minutes tonight.
Sure. Anytime
Thanks.
you need to leave, just tell me. No problem. I'm always willing to do that.
Okay, cool. Thank you.
Sure. Let's start with this one. And I will add that these free response questions are like bonus questions. In other words, I'm not a big fan of working with the hardest possible questions. I don't think it teaches you much about calculus. If you want to learn about calculus, you master the easy, and then you master the medium, and then you go on to the difficult.
Mm-hmm.
All right, let's have a look at this problem here. Well, first of all, I'm a little puzzled that it says it's differentiable on the closed interval. I can see 3 points where it's not differentiable. Am I missing something?
No, that's really weird, actually.
Not differentiable there, it's not differentiable there, and it's not differentiable there.
I'm not really sure what it's supposed to mean.
Yet it says it's differentiable on that interval, -6 to 5.
Oh, that's the derivative.
Now I get it. I just read the rest of the problem. We're not looking at the function.
Yeah, we're looking at the derivative.
We're looking at the derivative of the function. Okay.
Okay, that makes a lot more sense to me.
Yeah, it does. Find the values of f of -6 and f of 5. Oh boy. F of -6.
I'm not very sure how we'd even go about this.
Well, I got to think about this for a little bit. Let me see if I can draw a graph above this. Merely because that's what I'm used to doing, is drawing the function above the derivative. Okay? So let's try to draw the function. Well, the derivative is positive from -6 to -2. So that means the function is increasing from -6 to -2. So we'll just draw something like that. Okay, do you understand that?
Yeah.
Okay. Now, at -2, the derivative is 0. So we have to have a flat spot in the original function. And f of -2 has to equal 7. Well, that kind of matches, doesn't it? In other words, what I'm drawing on top is the original function. I'm trying to. Okay, and it tells me that f of minus 2 is equal to 7. Well, my f of minus 2 is equal to 7. Okay, you with me?
Yeah.
Kind of have to work backwards on these. These aren't easy, but you can kind of work it out. Okay, the graph of f prime, the derivative of f, consists of a okay, all right. Hold on a minute. Let me scroll down here and see what their questions are. Find the values of f of minus 6 and f of 5. Well, let's work with that only. So we know it's positive, it's increasing, or yeah, it's got to be increasing, right? In other words, if the original function is increasing, then the derivative is positive. Well, that derivative is positive between those 2 points. So the original function has to be increasing. But notice that its slope is decreasing. In other words, the original function is probably concave down. In other words, it must look something like that. Notice what the slopes are doing. They start out at that value, which is 2, and then they go to 1, and then they go to half, which is exactly what I have circled down below. Is they are gradually decreasing until they get to 0 when x is minus 2. Now it says that f of minus 2 is 7. Excuse me. Yeah, this is the original function. So that point has to be 7. So I can't be too far off with that. You know, comparing it to that. Now, let's see if we can finish drawing the graph of f, because that may actually answer our questions a little bit better. So between minus 2 and 0.
Would that be more like a cubic function, probably?
Well, not necessarily. No, I really don't know, to be honest with you. I kind of have to go from left to right and figure it out as I go from left to right. Okay, the only thing I know is that the derivative is negative, right?
Mm-hmm.
Okay, that means the original function has to be decreasing. Also, the derivative has a 0 slope right there and a 0 slope right there. So the original function has to have a 0 slope at those points. Now, let's see. We know it's decreasing, so it's got to be headed down. And what happens right here? The original function has a slope of minus 2. And the original function's slope is concave, so that, yeah, that actually looks like a slope of minus 2. And then the slope gets better. I don't know. Here, hold on. Let me think about this for a second. These are extremely difficult problems.
Yeah.
Just because you're trying to go backwards, okay? It's hard enough to go forwards. the fact that they want you to go backwards. Let's see what else we can put together here. I've got something wrong here. I'm not sure what it is, but the slope is 0 at 2. So that part makes sense, right?
Yeah.
That's 0 at 2. And then the slope gradually, it's positive from 2 to 5. So it's got to be in positive territory. So we're going to make it like that. And it's got to be increasing. So we're going to make it like that. So does that picture make sense with our derivative?
Yeah.
Well, I don't know. Let's see here. Let's see. The original function is increasing, therefore the derivative is positive. So that kind of makes sense. And the slopes are decreasing. That's a steep slope, medium slope, small slope. So they are decreasing. So the first part looks okay. And let's look at the last part. Okay, at x equal 2 in the derivative is 0. Therefore, we need a place like that at 2 in the original function. And this is all positive, so the original function has to be increasing during that whole interval, but it's increasing with increasing slopes here. Hold on. And it's increasing with decreasing slopes there. And that's why we get concavity. And this point is this point right here. Notice that if we look at the original function, our slopes are plus, 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 and the pluses are increasing numbers just like that is. But then they flatten out and they start decreasing, which is this. And the slope doesn't get to 0 until that point right there, which is the equivalent of that point. Okay? So I kind of feel like we have a reasonable approximation of the original function. Now, the one thing you're going to discover with calculus is that when they give you the derivative and you have to figure out the original function, that this is the shape, but it could be anywhere moved up or down. Just trust me. In other words, I could draw the original function like this. And it would still satisfy everything.
Because it's based on slopes, right?
Exactly. In other words, the original function on my pink is still increasing everywhere there. And it still has a flat slope at x equal minus 2. So when you try to draw the original function, you can draw the shape, but you can't place it on the y-axis accurately unless you have more information. And we do have more information. Just haven't gotten to it yet. But we have something that approximates the original slope, unless I've made a mistake. Okay? Now it says the original function f of minus 2 equals 7. Well, that tells me that it's not vertically shifted. It's right about there. That the original function f of minus 2 is equal to 7. So I've got the shape of the curve right, and I now have it placed correctly on the y-axis. So can we answer these questions? What is f of minus 6? Which is, what is that point right there on the original function? Well, my guess would be 0. I'm not sure exactly how to figure it out. Let me, maybe as we answer all 4 of these questions, we'll get a better idea on how to figure it out.
Okay.
What is f of 5? Well, f of 5 is that point. So the only thing I know that its derivative is 0. So it's a flat tangent line. But where it falls there, I'm not sure. No calculator allowed. Does that really matter? Can you read B to me? What is B asking? I can't look at B without losing everything I've written here.
Okay. Yeah, it's
What is B?
on what intervals is f increasing? Justify your answer.
All right.
So I go from.
That's an easy question.
Yeah, -6 to 2.
Is x increasing? Give me the intervals of that x is increasing.
-6 to -2. 0. Wait. Yeah.
Combination with what?
0 to 3.
No, it's wherever the derivative is positive. Where's the derivative positive?
Oh, so -6 to -2, and then 2 to 3.
2 to 5. It's positive in that whole area.
Oh.
The hardest thing with calculus is to differentiate between increasing and positive. Okay? In other words, that's decreasing, but it is still positive in that entire interval.
Mm-hmm.
That's increasing there, decreasing there, but it's still positive in that entire interval. So wherever the first derivative is positive, the original function is increasing. And that's why when we go up to the original function, I've got it increasing from there to there. Because it has to be. There is no part between 2 and 5 where it can be decreasing. The only thing that's changing is the slopes. And you can see where the way I've drawn it, the slopes go from steep to small, which agrees with this picture. So answering where it's increasing and decreasing is a piece of cake. Still not sure the answers to A. What's the question for C?
Find the absolute minimum value of f on the closed interval -6 to 5. Justify your answer.
And what do they want? The absolute minimum or maximum?
Absolute minimum. Would it be at 1 actually? Because that's the inflection point of. Wait. That's interesting.
It is interesting. That's an inflection point right there in the second derivative. But it's an inflection point of the original function. In other words, if I look at the second derivative of this function, I'm going to find it is 0 at 0. So, well,
my guess is it would have to be that lower curve.
Let's do this. Let's draw the second derivative.
Mm-hmm.
Okay, the first derivative is decreasing, so the second derivative needs to be negative, and the slope is the same the entire way. It's like minus 2. Okay? So the bottom curve that I'm drawing is the second derivative. The top curve is the original function. Just trying to figure out whether this enlightens us any.
Okay, well, so we know for the first one that it's going to be a slope of, would it be 1/2 or 1/3?
1, 2, 3, 4, 5. Looks like 2/5.
2/5, okay.
Minus 2/5. That's what, oh, now hold on. That's the slope of the first derivative. So this line occurs at minus 2/5. Remember, the bottom line is the second derivative.
Mm-hmm.
And it's a horizontal line because the slope is exactly the same from minus 6 to minus 2. The slope is minus 2/5. And then it's decreasing. So it's still negative, but it's getting closer to 0. It's got to get to 0 by there. And the slope starts steep. And decreases. Somehow it's got to get to that point. And then it increases. So it's negative to that point. Then it increases from that point to that point. And then it's a positive 3/2 from that point to that point. And then it's a negative 2 from that point to that point. So the second derivative might look something like that. I'm sorry to have to ask this again, but I can't scroll down and see the question for C or B without losing all my writing, and I don't want to do that.
It's just finding the absolute minimum value.
Okay, let's try to figure that out. Well, from my original curve, it appears to be there, right?
Mm-hmm.
Well, it's going to certainly be where the first derivative is 0, right? In other words, when we're trying to find relative or absolute minimums, we look for the first derivative to be 0. So, sorry, it's not where I just underlined it. It's the absolute minimum or maximum is either going to occur there, there, or there. That's where the first derivatives are 0. Now, where would that be? Certainly not at minus 2. Doesn't look like that's a minimum on my original function. I would say at plus 2. That comes closer to the minimum of the function, which is right there, than any other point. In other words, the original function that I drew is clearly just an approximation, but it's pretty close. It's not that far off. And where I know that minimums occur in the original function, the first derivative is 0. So I want to check all my 0 points in the first derivative. That's where the minimum's going to occur. I can even figure out more. Does the first derivative go from negative to positive? At 2.
Yes.
Okay. Well, if the original function looked like this, that would go to negative to positive. So this point, x equal 2, not only is my derivative going from negative to positive, which is the first derivative test, that's the test for a minimum point. That's the only point on the whole curve that goes from negative to positive, right? If I look at that entire first derivative, there is no other point that goes from negative to positive. And yet that's what has to happen for it to be a negative or a minimum. If the original function is a minimum, it's got to go from negative to positive with a zero slope. Well, that's what's going on right there. It goes from negative to positive, and the zero slope is right there, so that's got to be the minimum of the function, x equal 2. Do you have answers on these?
No.
Yes or no? I didn't hear that.
No.
Yes?
No.
No. Okay, too bad. Calculus, it always helps to have answers. Just it does. I mean, it's so hard that you really want to be able to check your reasoning and your logic. And the only way to do that is to have answers. But I'm relatively certain of this. I don't have any doubts at all. In other words, the first derivative test says that for something to be a minimum, the slopes have to lead into it being negative and they have to go out of it being positive. And there's only one point on the curve where that happens, on the derivative curve, right there. There's no other point where it goes from negative to positive. So that's the minimum. What's the other part B?
Then the next one is for each f double prime negative 5 and f double prime 3, find the value or explain why it does not exist.
Like this?
For f double prime of 3, it cannot exist because it's on a corner.
Good.
And f5 is just negative 2/5.
Not negative 2/5. It's the slope of that line. What's the slope?
Oh no, it's negative 5.
Negative 1.
No, it's negative 5. Sorry, not 5.
Oh, okay. Hold on. Let me go back. Negative 5 is right there. And that slope is negative 2/5. It's the slope of that line. In other words, the derivative of that is going to be minus 2/5 between that point and that point. That slope doesn't change. Whenever you have a straight line, the slope is constant, and it stays that. Okay, what else? What other question about this?
That's it.
For question 3, that's it?
Yep.
Okay. I think actually we got that one. What was that? This one here? No, it's a different one. I suppose it doesn't really matter which one we look at, does it?
It doesn't.
You don't have any preference or
Nope.
I can't tell which ones are going to be easier and which ones are going to be tougher. So let's just look at all of them.
Oh yeah.
All of these, I mean, this is brutal to do to you. The teacher is not doing you any favors by giving you this as your next assignment. He just isn't. But let's have a look. So they give you G prime, they give you G double prime, and they give you an initial condition. this is an initial condition. If you have the derivative, the heck is going on here? My calendar popped open, of all things. How do I close it out? Oh, just click on the picture. Okay, hold on a second. Let me. All right, what do we got here? All right. Trying to figure out how to best explain this to you. In other words, at some point in differential calculus, you get to a problem where they start giving you derivatives and they want you to figure out the original function. That's pretty much it. Although I don't know, let's look at these questions. Find all values of x on this particular interval at which g, the original function, has a horizontal tangent line. Well, what does that mean about the first derivative?
That
If the original function has a horizontal tangent line, what is the first derivative at that point?
linear slope.
It's 0. Here, let's look at a function. There's the original function, okay? There are two places where it has a horizontal tangent line, right there and there. So that would be one point where it has a horizontal tangent line, that's another. And the way I've drawn it, let's just have that go up like that, okay? So if they tell you that you have a horizontal tangent line, it means that the first derivative is 0. In other words, the first, in this curve that I just drew, the first derivative is 0 right there at that point. First derivative is also 0 at that point. So that's the first thing. So there's the first derivative, and they're saying, where is that 0? Well, let's let 0 equal the sine of x plus 1 over x. Now we have to solve that equation. Where's the sine equal to 0? Here's the sine curve. It's equal to 0 at 0 and at pi. So that has to be either 0 or pi. And the interval they gave us was between those two numbers. So pi's out of the question. So the only place we have to figure out is where the sine of x plus 1 over x is equal to 0. Well, that means x plus 1 over x has to equal 0. If I multiply both sides by x, I get x squared equals 0, x equals 0. That's not in our interval. Our interval is between 0.12 and 1. thinking. Are these calculator problems or not?
No.
No calculator allowed here?
I mean, I honestly, I don't, it doesn't say anything.
Ah, okay, I forgot to consider another possibility here. In other words, either we could be equal to 0 or we're equal to pi, right?
Mm-hmm.
The sine of x plus 1 over x, that's still 0, but that means x plus 1 over x could be equal to pi, because the sine of pi is 0. Now we have something a little more to work with. Upper right here, we got x plus 1 over x equals pi. Multiply both sides by x, I get x squared equals pi x. All right, that works actually. X squared plus 1 equals pi x. If I multiply both sides by x, and now I have a quadratic. X squared minus pi x plus 1 equals 0. I can solve that quadratic even if I have to use the quadratic formula. And both answers are going to be positive. I just can't believe they would ask a question this difficult at this stage of calculus. The teacher must have been sick and he didn't have any other problems to give you. That's my answer. I know that sounds silly, but that's what I think happened. It's the only excuse for giving you these level of difficulty problems. Hold on a second. We can still solve this. So we just have to solve this equation. And the answer is going to be in that interval. Well, at least one of them will. Well, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we plug it in. Minus b is pi, right? First of all, do you understand where that's a quadratic equation? Remember, pi is just a number. It's 3.14. Jake, you still there?
That was very weird. It was muted, but yes, I've been acknowledging you.
Okay, I didn't know if you were hearing me or not. Okay, so if we solve this quadratic, let's see if we can do it. That's pi squared minus 4 times 1 times 1 all over 2. So what does that give us? Pi plus or minus the square root. Do you have a calculator? What's pi squared?
Oh, I don't.
It's got to be about 12. Hold on, let me do it. 3.14 times 3.14 equals 9.86. So 9.86 goes there, minus 4 all over 2. So now we have pi plus or minus the square root of 5.86 all over 2. And the only answer, this is going to give us two answers, and we need one that's in this interval from 0.12 to 1. Square root of 5.86. Got to be 2 and change. So it's got to be pi minus, not plus. So it's going to be pi minus 2 and change, all divided by 2. That's the answer, 5.86. Pi minus the square root of 5.86 divided by 2.
That looks complicated.
I hate to say it, but this is almost a waste of time. First of all, let me tell you this. The free response questions on the AP Calc test are the toughest questions. If you're going to skip any questions, and I guarantee you will run out of time and you'll have to skip questions, skip the free response questions.
Would you say they're just a waste of time because they're so hard?
I'm not saying they're a waste of time. If you have a 180 IQ and you get through the AP calculus questions and you have time to work on the free response questions, then you can do them. But I'm just telling you that they are the toughest of all of the questions on the AP exam. Anything that says free response. So if I'm taking an AP Calc exam, I'm going to leave those for the last. I'm going to do everything else first, and then I'm going to try to do those. Okay? You understand what I'm saying?
Yeah.
So the question is why is your teacher giving you 10 questions that are all free response questions? He just decided to drop you on the expert ski slopes and let you go it alone. That's what he's done.
It's very hard.
Well, it's more than hard. It's ridiculously hard. Now, figuring out that is not hard. You give me the first derivative and I can take the derivative of that all day long. Okay? So notice what that is. That's the derivative of the outside times the derivative of the inside.
Mm-hmm.
So giving you the second derivative doesn't even help, because presumably if you have any chance at all of answering this question, you can certainly figure out the second derivative. Giving you the horizontal tangent line merely means that g prime of x has to be equal to 0. And there's going to be numerous places where it's equal to 0 because that's a sine function. Sine functions look like this. Okay, so there's all kinds of places. It's equal to 0 there, 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 and there. But it wants the 0 spot between those two numbers. So there's probably only one. So you not only have to solve the equation that sine of x plus 1 over x is equal to 0. In other words, this. In other words, this is definitely the next step. Sine of x plus 1 over x, that's the derivative, has to equal 0. And the only answers for x that work, there's going to be an infinite number of answers for x, but we're looking for the x that is in that interval. That makes it particularly hard. Because, well, sine of a quantity is only equal to 0 at pi, 2 pi, 3 pi, and 4 pi, and so on and so on. So x plus 1 over x has to equal pi, or it has to equal 2 pi, or it has to equal 3 pi, until we find an x that's in that interval. You understand what I'm saying?
Mm-hmm.
In other words, if the sine of x plus 1 over x was equal to pi, and that gave us an x that's in that interval, that's the answer. If it gives us an x that is 0.1, that's not the answer. We probably got to go to this answer. In other words, one of these is the answer. The only way I solve that equation is by turning it into a quadratic. In other words, I multiply both sides by x, I get x squared plus 1 equals pi x. And then that is a regular quadratic that I need to solve. And whatever the answer is to that quadratic, if it's between that interval, that's one of your answers. If it's not one of your answers, and you go to the next one. Yeah, I mean, it's so difficult that I'm not sure you're gaining anything at all from this session.
Yeah, if I'm being honest, I can't. It's really hard for me to grasp.
Well, I understand why. And like I said, this is a ding on your teacher. He had no business giving you these 4 free response questions. Just no business at all. Not a month and a half into calculus.
Mm-hmm.
But despite that, let's go on. We got 10 minutes. On what subintervals in that interval is the graph concave down? Justify your answer. Well, when is the graph of a function concave down? What's the second derivative when it's concave down? Positive or negative?
Positive?
Negative goes with down, positive goes with up.
So negative.
Negative. So that, and here's what the second derivative is. Okay? So what they're saying is this. That has to be negative. I gotta believe this is a calculator question. I just gotta believe it. There's no way they expect you to do this without a calculator. So let's solve it with a calculator. So remember what this second derivative is. You read it to me because I got to go. Oh, I can see it. Sorry. I'm going to do it on Wolfram Alpha, and I'm going to give you the definitive answer to this thing in a way that you can understand. This function, the second derivative, they want to know where this function is equal to 0. So the function is 1 minus 1 divided by x raised to the 2 times cosine of x plus x raised to the minus 1. Let's look at this second derivative function. Didn't like the way I typed it in. What's wrong with the way I typed it in? 1 minus 1 over x squared times the cosine of x. I put an equal sign there instead of a plus sign. Now, let's see if that produces anything. Is that our proper second derivative? It is. And what we want to know is where on this interval is it equal to 0? That's what it says on question B. Excuse me, sorry. Question B says, where is it concave down, which means where is it negative? Well, let's take a look again as to where it's negative. Between that point and that point. You see?
Mm-hmm.
So that point we'll call negative 4.5. And that point is negative 1.1. And it wants the interval between plus 0.12 and 1. Well, in other words, those points weren't valid because they were negative. So I need to find points to the right of the x-axis where the function, the second derivative is 0. That's right there. Can you see my cursor?
Yeah.
And that's in the interval. Whatever that is. Unfortunately, my cursor doesn't tell me what that point is, but I'll bet it gives me the zeros of this. X equal 1. That's the root of the second derivative. So when x equals 1, the second derivative is 0. That's not what we want. But if we look at the curve, it's negative starting from there. Yeah, if the second derivative is negative, then the interval of the original function is concave down. So the original function, I wonder why it stops giving you the curve at this point. I don't know why Wolfram Alpha does that. Which is problematic in this case. I'm assuming, can you see where my cursor is?
Mm-hmm.
I'm assuming that it does exactly the same to the right as it does to the left. In other words, it follows a sine curve. Like that. Okay? So where is it negative? It's negative from that point to maybe that point. Now you could put this into your Inspire and you could get the exact interval where the second derivative is negative. I can't seem to get it on Wolfram Alpha, but you can get it on your calculator. I know you can. If you put in this function into the Inspire, that function right there, that's our second derivative function. It will tell you where that is negative in the interval 0.12 to 1. And that's the answer. Whatever the interval that your calculator shows, that's the answer to the question. And that's why I'm so certain that this is a calculator question. In fact, I think every free response question is a calculator question. When I think back on the AP test, I've looked at it frequently. I've got a number of practice tests on my computer, And when I think back of all of the free response questions, they are all calculator questions. And in fact, probably most of them require, you're not going to be able to answer them without a calculator. Now, unfortunately, my version of Wolfram Alpha doesn't give me the graph to the right of the y-axis. And yet the interval they're asking about is to the right of the y-axis. It's from 0.12 to 1. This isn't helpful, what I'm looking at here. So you need to put the function that I've put in into your calculator and figure out where it's negative in the interval 0.12 to 1. And that's the way you would answer that question. So even though this question is ridiculously hard, there are parts of it that you can answer relatively easy. In other words, you got to memorize that concave down of the original function means the second derivative is negative. That's something you have to know. Otherwise, you got no shot on this question. But if you know that, then they give you the second derivative. We just have to figure out where that's negative. Well, that's not an easy algebra problem. You almost have to be able to graph that and look where it's in negative territory. And that's your answer.
Mm-hmm. It kind of makes sense, yeah.
All right, we got 2 minutes. Let me just touch upon part C. I'll try to touch upon each of these. Write an equation for the line tangent to the graph at x equals 3. Well, what's the slope going to be? The slope's going to be the first derivative, right? So g prime of 3, in other words, our slope of our tangent line is going to be g prime of 0.3, which is the sine of 0.3 plus 1 over 0.3. And all of that has to equal 0.3. Excuse me. The sine of x plus 1 over x, that is the slope at any value of x. That's what first derivative means. It means whatever value of x you want to give me, I can tell you the slope. And this question says at x equal 0.3. So it's whatever this is equal. That's the slope. And once you get a slope, then you can use point slope. In other words, you can use this. Y minus y1 equals m times x minus x1. Well, whatever that answer is, that'll be m. And the point, x1 is 0.3. And you have to calculate what y1 is by plugging in 0.3 into the original equation, which they don't give us. Jesus. Oh, frick. Is this a substitute teacher? Was it
No.
a regular teacher?
I'm a normal teacher.
Your regular teacher, and he gave you all these problems.
Yep.
All right. Well, I don't know what else to say. We're out of time. In fact, we're over time. So let's just call it a session, and then we'll pick it up again on Tuesday, and hopefully you'll have regular questions, not
Yeah.
AP Calculus AB exam free response questions.
Yeah, this is
All right.
ridiculous.
I'll talk to you next time.
All right, see ya.
Bye-bye.